Welcome to this journey through the fascinating world of salts. Have you ever wondered why not all salts are made the same way? It's because they differ in solubility, reactivity, and how they interact with acids and bases. By studying specific salt preparations, we learn which method works best for each type, how to get a pure product, and how to achieve a high yield, all of which are essential skills in both laboratory work and industrial chemistry. Let's begin with one of the most familiar salts, sodium chloride or common salt. Commercially, it's obtained by evaporating seawater or mining rock salt. In the laboratory, we prepare it by neutralizing hydrochloric acid with sodium hydroxide, which gives sodium chloride and water. The reaction is hydrogen chloride plus sodium hydroxide gives sodium chloride plus water. The resulting solution is gently evaporated to leave behind pure sodium chloride crystals. Looking for vibrant blue crystals? That's copper 2 sulphate. It's prepared by reacting black copper oxide powder with dilute sulfuric acid. This acid-base reaction produces copper sulphate and water, shown by the equation copper oxide plus sulfuric acid gives copper sulphate plus water. Any excess copper oxide is removed by filtration, and the copper sulphate is obtained by evaporating the filtrate. Not all salts dissolve in water, and that's exactly why lead 2 sulphate is made using a precipitation method. We mix lead nitrate solution with sodium sulphate solution, and a white precipitate of lead sulphate forms. The reaction is lead nitrate plus sodium sulphate gives lead sulphate precipitate and sodium nitrate. This insoluble salt is then filtered, washed, and dried. It's a classic case of double decomposition. Let's scale up. When it comes to industrial salt production, sodium carbonate is made using the ammonia soda process. In this method, sodium chloride reacts with ammonia, carbon dioxide, and water to form sodium hydrogencarbonate, which is then heated to produce sodium carbonate. The overall reactions are sodium chloride plus ammonia plus carbon dioxide plus water gives sodium hydrogencarbonate and ammonium chloride. Then, sodium hydrogencarbonate on heating gives sodium carbonate, carbon dioxide, and water. This process is widely used in the manufacture of glass, soap, and paper. Here's a salt that forms almost instantly, ammonium chloride. It can be made by neutralizing ammonia solution with hydrochloric acid, forming ammonium chloride and water. Or even more dramatically, by combining ammonia gas with hydrogen chloride gas, which produces a white solid cloud of ammonium chloride on contact. The reaction is ammonia plus hydrogen chloride gives ammonium chloride. This salt is commonly used in dry cells and as a nitrogen-rich fertilizer. From fertilizers to fireworks, potassium nitrate is an incredibly useful salt. It's prepared by reacting nitric acid with potassium hydroxide, forming potassium nitrate and water. The reaction is nitric acid plus potassium hydroxide gives potassium nitrate plus water. After the solution is prepared, it is filtered and evaporated to yield pure potassium nitrate crystals. Let's summarize what we've learned about making specific salts. First, the method used depends on solubility and reactivity of the substances involved. We commonly use neutralization, precipitation, or direct synthesis to prepare different types of salts. Sodium chloride, ammonium chloride, and potassium nitrate are all made through neutralization methods. Copper 2 sulphate is made from an insoluble base, while lead 2 sulphate is prepared by precipitation. Finally, in industry, salts like sodium carbonate are produced on a large scale using the ammonia soda process, which ensures high yield and efficiency.